Good afternoon. My name is Stefania Riva, and this presentation is a part of a job that I did during the last month at the University of Milano-Bicocca at the Material Science Department under the supervision of the Professor Simona Binetti. Just to give you a little bit of introduction about myself, I studied at the University of Milano-Bicocca for my bachelor's degree and also for my master's degree that are in physics. And in particular, for my master's thesis, I studied the solar cell called the CZTS. In 2021, I worked at the RM Schools project for the University of Milano-Bicocca, but right now I am hired at Uppsala University in Sweden for the PhD. But the discussion of today is the overview of silicon photovoltaic panels from the basic theory of functioning to their end of life. And the outline of this presentation is as following. There are three different parts. The first part is the basic principles of photovoltaics and how it works. The second part is the technology of the crystalline silicon panels. And the third part is the recycling of PV panels. So we start with the basic principles. And here there's a video about photovoltaics. And this black is a silicon cell, which is 10 centimeter per 10 centimeter. And it is connected electrically to this wind turbine. And there's also a lamp. And when the lamp shines, the silicon cell, the wind turbine starts working. And when the silicon cell is covered, the wind turbine slows down and stops working. Okay, so that process is the photovoltaic. And if we want to look better at the word photovoltaics, we can see that it is can be divided in two parts. The first part comes from the word phos, coming from the Greek, and it means light. While the second part of the word is the word comes from the word volt, which is the unit of measurements of the voltage, and this is related to the electric field and so to the electric current. And in this scheme, you can see the sun that shines solar cell, and there is some movement of charges inside the material, but at the end, the charges are collected, and they can switch on a lamp. And so it's important that you could remember that photovoltaics is the conversion of the sun energy into electricity. And why photovoltaics? As you can see, in order to produce electricity, there is the need of a source. In our case, the source is the sun that is diffused all around the world. And the second motivation why photovoltaics works is that the solar energy is abundant, and in fact, we can say that in 1 hour and 30 minutes, the sun energy could handle the entire world's energy consumption for a full year. Looking better at the source, that is the sun emits sunlight or sun rays, and they are rays with a certain wavelength. Knowing the constant, like the speed of light and the Planck's constant and the wavelengths of the ray, is possible to find the energy of the ray. And the sunlight can be also seen as a particle, and the particles of light are called photons. And they have different energies. So if we count the number of photons at a certain energy, we can obtain this graph, which is a spectrum. In this case, it's the sun spectrum. And as you can see, there is a large part of the spectrum that is in the visible light, and the energy of the visible light is between 1 and 3 electron volts. In order to exploit such energy, we need some materials that have the proper properties. And in this case, this is the silicon. And looking at the silicon, you can see that the silicon is formed by atoms. And but looking deeper again, it's possible to look at the electrons. And this is a band diagram where we can consider two bands. And the first one is the band called valence band. In order to understand, it's like it's a band full of electrons. And there is another band which is empty of electrons, and this is called conduction band. But in this case, we can call it empty band. The distance in energy between these two bands is called energy gap. And this is important because all the materials can be classified according to this energy gap. Indeed, we can have insulators, semiconductors, and metals. But since we want to exploit the solar energy, that is mostly indivisible, so it's 1 to 3 electron volt, the best materials that can be used for this type of application are the semiconductors. And in particular, in this case, here is the silicon with a band gap of 1.1 electron volt. Here we have a photon, and the photon shines the electron. And when this happens, the electron absorbs the light from the photon, and the electron is excited from the full band to the empty band. And there is a process called charge separation, where the electrons goes in the empty band, and there is a vacancy. And this vacancy is called hole. And the electron here can be extracted to produce current and so electricity. Now we are going to talk about the photovoltaic technology. And nowadays, the dominant technology for photovoltaics is based on crystalline silicon. And from this data from 2014, 92% of the market is in 2014 was dominated by crystalline silicon. But why silicon is so important, and why the silicon photovoltaic is the most dominant one? And there are different motivations. The first one is that the price of solar modules is low, and it is $0.20 per watt. The silicon photovoltaics is based on silicon, which is the second abundant element on Earth. Then the silicon panels are not toxic. The solar cells in the silicon panels have a good efficiency. They have also long lifetime because at least they can work at least 25 to 30 years. And recycling processes have been developed, and there are also right now recycling processes. But producing silicon is not easy. A lot of energy is used to purify and produce crystalline silicon. The process starts with the silica that is heated at high temperature. Then what is obtained, which is a metallurgical silicon, is purified. And then there is a crystallization process when the silicon that is without impurities becomes solid. And then it is sliced in order to obtain the silicon wafer. But this is not enough. It's important to have two layers made of silicon called P-type and N-type. And also there are the need of other materials such as metals, aluminum, and silver. And the total thickness is 200 micrometer. And in order to understand better how much is 200 micrometer, we can consider the length of an ant, that it is more or less 5 millimeters. So if we imagine to have an ant and to cut it in 25 parts, we can obtain 200 micrometer. But this is not enough in order to produce energy. 36 solar silicon cells are needed to be connected as in this way. And there are also other materials. And the silicon module is glued with a polymer called EVA. And there are other materials such as glass and aluminum, and there is a plastic for insulating the module, and a conjunction box for the strings. Here is a video from the toolkit recycling of silicon-based PV module. When it's a video made in the University of Milano-Bicocca, where you can see the assembling of a little module, and here is the glass, then the polymer, the silicon, again the polymer, and the glass again. And just to be more clear, a silicon cell is 10 centimeter per 10 centimeter. If we put together 36 cells, we form a module. And putting together different modules, there is the formation of a photovoltaic panel or solar panel. And this is another concept that can be useful, because I said that it's that producing silicon requires a lot of energy, but there is this other parameter which is called energy payback time, that counts the amount of time that the PV system needs to operate to recover the energy that went into making the system. So it's the amount of time that the photovoltaic system needs to work in order to produce the same amount of energy that was used to produce it. And in general, this is almost 1 year, depending on the region where the installation of the photovoltaic has done. And looking better at the materials that form the photovoltaic module, you can see here that we have 4 main components: glass, aluminum, silicon, and silver, where the most abundant element in this solar module is the glass. But looking better at the value, the price per kilogram, you can see that the silver is the most precious material. And multiply the weight by the price per kilo, we can obtain the value in percentage. And so we can say that some materials are more precious than the others: silver, silicon, aluminum. And the question that we are going to answer later is that if there is a way of recovering these photovoltaic modules. Every finite product should follow this cycle called circular economy. When we start from the raw materials, then the product is produced and it is used, and at the end of the life, the product is recycled. And this chain is in order to reduce the waste and reduce the waste to a minimum. And this is also what is important for the silicon photovoltaic modules, that after the use of the modules, at the end of their life, they can be recycled. But it's not just about recycle, but there are other ways of reducing the waste. The first one is reducing the material used. And so the first thing to reduce is to reduce the thickness of the materials. And this is done for the silicon, because during the years, the thickness of the silicon has been reduced. And also it's important that the silicon panels that don't work anymore can be repaired and then reused. Installations of photovoltaic panels started in 1992. Since then, there has been an exponential growth of the photovoltaic installations. And there is a forecast that by 2050, there will be more installed panels. And since, as you can remember, photovoltaic panels have a lifetime of 25 years, there is a prediction that by 2050, there will be 10 million tons of end-of-life panels. And recycling is important and worth, because from different point of views. The first one is the economical point of view, because it's recycling panels can save materials, and indeed, if all the materials that can be recovered by the 2050 can be used to produce 2 billion new panels, and also can be important to recover the recycling photovoltaic panels, because this way we can it's possible to reduce the CO2 emission and this way we can use the materials that already are on the market without extracting new materials. The photovoltaic panels are inserted in as electric and electronic wastes. So as just to make you understand, they are considered as a waste as the telephone, computers, and electronic products. And the regulation from EU gives to the producer the responsibility for the end-of-life management, so the collection and the recycling. To recycle, the first thing we need to do is to separate the different layers, and this way trying to recovering the glass, silicon cells, and other precious metals. There are different processes, 3 different approaches. The first one is mechanical, and this means having the panels separate the different layers and crush for example, the glass and also the silicon. The second approach is the thermal approach, where high temperature is used to divide the layers. And here is a video from the recycling of silicon-based PV modules, where these PV modules was on the heating plate. And since the encapsulant, the glue, with the heat, it now is molten, and so the mini module can be opened. The third approach is the chemical one, where PV modules are immersed in a solvent, and the components are separated by chemical reaction. But in general, a combination of the 3 processes is preferred, because the recovering yield is higher. From studies, we can say that more than 85% of the panel can be recovered, and the material can be used again for a new life. And in this picture, we have the life cycle of the glass, where this is the recycling. There is also the recycling part of the glass, and the glass can be inserted in this cycle and be used again.